The discussion topic in this video is how to convert a decimal number to some another base r, and that decimal number will be only a whole number. This is the part of our number system and conversion series. So we are given a decimal number which is a whole number, and we have to convert it into some another base r. The method that we will follow is repeated division by the target base r, and we will understand the process using both the calculator and without calculator. What is meant by target base? So in this case, we want to convert this decimal number into its binary equivalent, so our target base is 2. In this case, our target base is 8 because we want to find the octal equivalent. Here our target base is 16 because the target is basically to find the hexadecimal equivalent. Here this number 497 will be converted into base 5. So target base is 5. Here we will convert this number 651 into its target base hexa, that is 16, but we will use the calculator for this example. And then another number 49 will be converted into target, that is octal, and our target number base will be 8. But we will perform this calculation using both the calculator and without calculator. Let us convert the number 255, which is a decimal number and a whole number, into its binary equivalent. So target base is 2. So we will perform the method using repeated division by 2. What is meant by that? The given value is 255. I will divide it with 2 using normal paper pen method. This portion is your quotient and this is your remainder. How to assemble this answer? Draw two parallel lines, write the original number 255 and our divisor is 2. Then we will write the quotient part over here, and this is our remainder. Very first remainder that you get is your least significant bit. And also, because you are converting it into binary, so all the remainders will be either 0 or 1. Again we will perform the division with 2, but this time what will be my dividend? This quotient will become your new dividend, and you will perform the calculation or the division process again. So how long should I continue? Till this quotient part becomes 0. So let me do it quickly. Now we will divide 63 with the 2, and our quotient is 31 and our remainder is 1. Now we will divide 31 with 2, and our quotient is 15 and remainder is also 1. Now this is our 15 is our now new dividend divided by 2. 7 is the quotient, 1 is the remainder. 7 divided by 2, 1 is the remainder. 3 divided by 2, 1 is the remainder. We'll continue till we get 0 in the middle section, that is over here. So 1 divided by 2, and this is your final bit, final remainder, and this is your most significant bit. So how you are going to read the answer? It is from bottom to top, that is from most significant bit onward to least significant bit. You start writing in this direction. You know, very first bit is always the most significant bit. So 1 1 1 1 1 1 1 1. It is group of 8 bits. Always cross check your answer so that you have not omitted or left out any remainder. Reading in the wrong direction will give us wrong result. Let us convert the number 255 in decimal. This time my target base is 8, that is into octal equivalent. So the method remains same. This time we will divide the original number 255, but my divisor is 8. So if you continue your calculation, remainder will be 7 because it is octal number, octal equivalent. So your remainders will be from 0 to 7. So 31 is your quotient and 7 is your remainder. Now we will divide 31 with 8 and your remainder will be again 7. So 8 divided by 31 divided by 8, 7 is the remainder, sorry, 3 is the quotient and 7 is the remainder. Now 3 divided by 8, that becomes 0 and 3. So we will read all the remainders from again bottom to top, and our final answer is 377. This is your most significant octal digit and this is your least significant octal digit. Writing the answer in wrong direction will give me wrong results. So be careful in writing your answer. Now let us convert the number 255, but this time my target base is 16. So 255 divided by 16, right? So when you do your division process, your quotient will be 15 and remainder will also be 15. Now 15 divided by 16, this will become 0 and your remainder is 15. For 15, we know its hexa equivalent is F. This is your least significant digit and this is your most significant digit. And we will write all the answers, remainders from bottom to top. So answer is double F in hexa. This time we have the number 497, but our target base is 5. So this time our divisor will be 5. So we will continue with our normal division method and our quotient will be 99 and remainder will be 2. Remember, by base 5 number system will have values from 0, 1, 2, 3 and 4. Now we will divide our quotient 99 with 5 again, and this time my remainder will be 19, quotient will be 19 and remainder will be 4. Now I will divide 19 again with 5 and my quotient will be 3 and my remainder will be 4. And I will divide again this 3 with 5 and this time my quotient will become 0 and my remainder will become 3. So having read all these numbers from bottom to top, I will have answer 3, 4, 4, 2. But remember that this time your base is 5. Similarly, you can be asked to convert the number into some base like base 3, 4, 6, 7 and so on. Now we have this number 49 and this time our target base is 8. First we will perform this example without using calculator. So if I divide 49 with 8, my quotient is becoming 6 because 8 6 is 48, my remainder will be 1. And then 6 divided by 8, my remainder will become 6. If I read all the remainders from bottom to top, my answer is 61 in octal. This was without calculator. But now we will use the calculator. So 49 divided by 8. So we are going to write like this. So I have taken the screenshot of my calculator over here. 49 divided by 8 will give me 6.125. See, remember your quotient is now made up of the whole number part and the fractional portion. Now I will continue dividing it with 8 till my this whole number part of the quotient becomes 0. So I will now divide 6 with 8 and you can see my answer here in the calculator is 0.75. Now this is now 0, so we will stop dividing the further. But where my remainders have gone? So now I will multiply this fraction part with our target base to get the remainders and I'll multiply in the same sequence as they have got generated. So 0.125 into 8, 0.75 into 8. You can use your calculator for this. The answer you will get is, in this case, when you multiply this 8 into 0.125, your answer will be 1, and 8 into 0.75, your answer will be 6. You will read all these remainders from again bottom to top and see your answer is same in both the cases, either with calculator or without calculator. But when you are using calculator, this is an additional step where the fractional portion of the quotient part should be multiplied with the target base to obtain the final remainders. Now we have the number 651 and we want to convert it into target base hexa, that is 16. We will use calculator for this purpose. So 651 divided by 16, that will give me 40.6875. My quotient is made up of whole number part as well as the fraction part. Now I will continue dividing till my this whole number part of the quotient becomes 0. So 40 divided by 16 will give me 2.5. Now I'll divide this 2 again with 16 and that will give me 0.125. These are the screenshots of my calculator. Now you have reached 0, so you will stop dividing further. Now to take the remainders, we will take this fractional portion in the same sequence as they have got generated and we will multiply them with our target base 16. And that multiplication will give us our remainders. So this will, you can use calculator for this purpose. You will get answer 2 over here. 0.5 into 16 will give me 8 and this will give 0.6875 into 16 will give me 11 and 11 is equivalent to B. And you have to read all your remainders again from bottom to top. So this is your least significant digit and the last remainder which you got is your most significant digit. So your answer is 28B in hexa. Now these are some of the rules which I have summed up over here. For the integer portion, in case of decimal number, we will repeatedly divide by the target base. We will divide the original number by the target base. Then we will continue dividing with the target base our resulting quotient and we will continue till the quotient gets 0 and then you have to read all the remainders from bottom to top. So this is important. First remainder will be your least significant digit and last remainder is the most significant digit. We'll wind up the session over here. Thank you for viewing. You can always subscribe the channel and share the video with your friends. So I'll meet you in the next video. Till then, take care and bye-bye.